Hello and welcome to this new episode of Reer Academy. Today I would like to speak about the safety device selection process and specifically the selection criteria of a safety light curtain. The goal of the selection process is to minimize the operator's risk of injury. To make the correct choice, the following factors must be considered. Machine characteristics. What type of machine do we have? What access area is available around the machine? Is the machine ejecting components? How long does it take for the machine to stop? Etc. Environmental characteristics. For example, is the machine vibrating? Do we have ambient light interference? Are we working in a dusty environment? Is the ambient temperature particularly cold or hot? Human characteristics. Why is the operator at risk? What part of the body do we need to protect? Fingers, hands, legs, or the entire body? Light curtain mounting options. How is the light curtain installed? Vertically, horizontally, or diagonally? Safety light curtain characteristics. How tall is the light curtain? What is the operating range? And more importantly, what is the resolution available? Next, we will analyze the light curtain detection capability in relation to human and machine characteristics. The correct positioning of the light curtain with respect to the hazardous zone. The necessity to install additional safety devices, for example, additional light curtains, sensors, switches, or gates and fences. As in the previous episode, I will be talking about specific safety devices, safety light curtains and safety light grids. Since the main function of the light curtain is to detect parts of the human body, fingers, hands, legs interacting with the machine, the predictable maximum operating speed of the machine should be considered. Safety light curtains mainly perform the following functions: crossing detection function, presence detection function, combination of crossing and presence detection function. In this episode, we will look at different light curtains resolutions, depending on the type of detection required by the application: finger, hand, and body detection or access control detection. When the operator is working closely to the dangerous point and, for example, a finger or hand detection is required, the resolution of the light curtain must be between 14 and 40 mm. When it is necessary to verify the operator's presence in a dangerous area, for example in front of a machinery, the light curtain is positioned horizontally, allowing for the continuous monitoring of a presence in that area. The resolution of the light curtains depends on the height of the detection plane, but cannot exceed 116 mm. On the other hand, if the goal is to detect a person accessing a dangerous area, the ideal type of protection is perimeter guarding on one or more sides of the dangerous area, even over longer distances. These light curtains must be placed at least 850 mm from the dangerous area and normally have a resolution of 2, 3 or 4 beams. In the case of an operator crossing into the hazardous area and remaining undetected within the dangerous area, the accidental start-up of the machine must not be permitted. There are several ways to prevent this from happening. Use of a start-restart interlock function. Positioning the restart button in a position that allows the full visibility of the dangerous area and where it cannot be reached by anyone from inside the dangerous area. Use of additional presence detection devices within the dangerous area, for example, light curtains used as presence sensing devices. Use of physical barriers, preventing the operator from accessing the dangerous area without being detected by the safety device. Once we have decided which type of light curtain to use, the following question is: what is the correct positioning of the safety light curtain? The light curtain should be positioned at a sufficient distance from the machine hazardous point, safety distance, to ensure the machine can stop or otherwise reach safe condition before any part of an approaching operator can reach the hazardous zone. The formula for calculating the safety distance is S is equal to K multiplied by T plus C. The formula takes into account three main factors. 1. Speed at which the body is approaching the dangerous zone, K coefficient. This calculation is expressed in millimeters per second, and the value is defined by the norm ISO 13855. 2. Total stopping time of the machine, T coefficient, consisting in the reaction time of the light curtains plus the reaction time of the machine. 3. The additional distance, C coefficient, expressed in millimeters depending on light curtain characteristics like type of detection and type of mounting. Don't be intimidated by this calculation. There is a safety distance calculator on our website that covers all possible scenarios according to the standards. As you can see, you simply enter the data into the calculator and wait for the result. The safety distance calculator should be easy to use. At least I hope. Maybe we will explore this in more details in a future episode. Well, it must be 5 o'clock somewhere. It's time to enjoy one of those famous Reer beers. Oops. We still have one last issue to address before we can relax. The calculation could return a recommendation for excessive safety distance, which would not allow the operator easily work with the machine or would not fit within the available space. So, what can we do? We have two possibilities. 1. Reducing the total stopping time of the machine, reducing the T parameter. 2. Improving the detection capability, resolution of the light curtain, reducing the C parameter. All we need to do is to recalculate the safety distance according to the new parameters. We must also consider environmental conditions. For example, under certain circumstances, the presence of reflective surfaces could create an alternative path for the beams, thus preventing the light curtain from detecting them correctly. That's all for today. I'll wait for you in the next episode of Reer Academy.